Dear students, in this video, we'll see a problem in linear time invariant system. The problem is show that if x of t is the input process, which is WSS with the average value 0 and the autocorrelation which is given, then the output process y of t given as 2 plus x of t is also WSS. Now, average of output process y of t can be found out by just taking expectation, right? So, expected value of y of t is the same as expected value of 2 plus x of t. Expected value will not affect the constant, so it is 2 plus expected value of x of t. Since x of t, which is the average of input given as a 0, so we use a 0 here, so the 2 plus 0 is equal to 2. Again, on calculating autocorrelation of the output Ryy of t comma t plus tau, it is defined as expected value of y of t into y of t plus tau. So I just supply what y of t is. It is given as a 2 plus x of t, and a t plus tau means 2 plus x of t plus tau. On multiplying, we get 4 terms. 4 plus 2 times x of t, 2 times x of t plus tau, plus x of t into x of t plus tau. So expected value on applying this, it leads to 4 times plus 2 times expected value of x of t plus 2 into e of x of t plus tau plus expected value of x of t into x of t plus tau. On applying the definition to this last term, it is nothing but autocorrelation of x, and as expected value of x of t is 0, average value is 0, that average value will not affect for any time t. Even if the time is a t plus tau, again the average is going to be only 0. Okay. So the first term is 4, second one is 0, and the third one is 0, final one is autocorrelation of tau. So this leads to 4 plus autocorrelation of x involving only term. Hence, output process y involves only the time difference tau. We can conclude that this output is a WSS process. The next problem is prove that the average of the output of a linear system is given by mu y equal to h of 0 into mu x, average of input, where the input x of t is a WSS process. Right. So to prove this, we need the definition of y of t, which is given in the form of a convolution. H of t convolution x of t. So applying the definition of convolution, it gives minus infinity to plus infinity, h of u x of t minus u into du. Here the input impulse response is h of t. So we just apply the expected value on both sides. So e of y of t is nothing but expected value of negative limit to positive limit h of u x of t minus u into du. So expected value will not affect this input response, unit impulse response. So expected is applied only to the process x. So E can be what taken inside. So it leads to E of x of t minus u. Okay. Already we know that x input is a WSS process. Its mean is a constant. When E of x of t is a constant, it is not going to change over time t. Again, E of x of t minus u is also the same mu x, which is going to be a constant. So we just replace mu x for E of x of t minus u. So this equation E of y of t reduces to minus infinity to plus infinity h of u mu x into du. This mu x will not affect, average will not affect this integration. So as it's a constant, so we put outside, it is mu x into minus infinity to plus infinity integral h of u du. We would like to find the transfer function h of omega. It can be obtained by taking Fourier transform on unit impulse function. So just apply the definition minus infinity to plus infinity h of t e power minus I omega t into dt. Since time t is involved in unit impulse, we use integrator as a dt. So just replace omega as a 0, so that we'll get h of 0 equal to minus infinity to plus infinity h of t e power 0 into dt. So e power 0 is 1, it will not affect. It leads to minus infinity to plus infinity h of t dt, which is same as minus infinity to plus infinity h of u into du. And integrator depends, sorry, integral depends only on the integrand, not on the integrator. So du dt, it will not affect the integral result. So we can use the symbol u instead of a t, so that I can use h of 0 as minus infinity to plus infinity h of u du. So expected value of this output is nothing but average of input into h of 0. This proves the result. Thank you.